Hello and welcome to Smart Indian Agriculture on the federal.com. I am Vivian Fernandez. On 8 April, Cabinet approved a scheme to supply fortified rice through ration shops, Anganwadis and schools. This program will cover 291 districts by March 2023 and the whole country by March 2024. Fortified rice is rice reconstituted with micronutrients like iron, folic acid, and vitamin B12. These micronutrients are mixed with ground rice and extruded under heat to form kernels of the same size and shape as normal rice. 10 kg of fortified rice is supposed to be mixed with 1 kg of normal rice. There is no change in cooking procedure and the taste is apparently no different. But can plants be engineered to produce staple cereals with enhanced nutrition? And is that a better way of delivering nutrition? To discuss this, we have with us Dr. Ashok Kumar Singh, Director of the Indian Agricultural Research Institute. IARI is a
Hello.
premier institute that led the Green Revolution along with Punjab Agricultural University and Pantnagar University. It has produced blockbuster varieties of basmati rice like Pusa Basmati 1, Pusa Basmati 1121, and Pusa Basmati 1509. In fact, Dr. Singh led the team that developed Pusa Basmati 1509. Apparently, more than 90% of basmati grown in the country originated at IARI, more than 60% of wheat are of IARI origin, and more than 50% of high-yielding mustards have also come from the same institute. IARI is called Pusa Institute because it was originally located, it was founded at Pusa in Samastipur district of Bihar. In fact, Dr. Singh is sitting in front of a replica or an image of the Pusa Institute, the original Pusa Institute. In 1934, after the earthquake in Bihar, it was relocated to its present campus in New Delhi. Dr. Singh, thank you very much for making the time, and it's a pleasure to have you.
Thank you, Vivian. Thank you for this golden opportunity given to me.
Sir, as a consumer, I would like to consume biofortified cereals enhanced with nutrition rather than reconstituted cereals. Now, do you think that mine is an unscientific prejudice, or do you think that I should be agnostic about the way in which cereals are fortified, whether they are fortified in an industrial manner or natural manner? What do you suggest?
So I think it's a very important question that you have raised. There is one important parameter, what we call as bioavailability. Now, when we take any micronutrients through a food, what proportion of that is available to our body is what is called as bioavailability. Now, the bioavailability of micronutrients, when it comes from the natural food matrix, when the nutrient is part of food matrix, is definitely much better, higher in terms of quality, quantity, as compared to when we are using fortified food. Because in fortified food, as you rightly explained about the rice, rice fortification with iron, zinc, or folic acid, the nutrients added are not part of the food matrix per se. So their bioavailability is low. But certainly, as a short-term solution to address the problems which are very, very important to be addressed in terms of malnutrition, this is a quick approach. There is no doubt about it. But long run, biofortification is the most sustainable option.
Sir, I was doing a quick scan of IARI annual report for the past 10 years, and I find that a lot of work has gone into the biofortification of wheat. For example, in 2019, a wheat variety was released with the 42.5 parts per million iron and 27 parts per million zinc. In 2020, another wheat variety rich in protein and iron was released. But there have been no releases of biofortified rice in the past 10 years. And I'm asking you this because you are an expert in rice plant biology.
So to tell you, in the Indian Council of Agriculture Research as a whole, which has number of institutions, including IARI under it, we have released 87 biofortified crop varieties till date. And out of these 87 varieties, they cover 16 different crops, including rice. Wheat and rice have got maximum number of biofortified varieties. In rice, we have zinc Bio-fortified rice and varieties like CR Dhan 810, 811, etc. have been released from Central Rice Research Institute, Cuttack. With iron in rice, we have a problem because most of iron is localized in the external layer that is called alluran or bran, and bran is removed during polishing. So because of that, iron goes out, only hardly 2 ppm iron is left. But zinc level, we have been able to achieve up to 24 to 28 ppm parts per million in rice. So total number of varieties, 87, and 29 of these varieties were dedicated to nation by Honorable Prime Minister to alleviate the hidden hunger.
So what is the reason IARI has not developed this? Is it because you tend to specialize in maize and wheat?
We have a very strong, biofortification program in rice as well. And in maize, we have developed some 10 hybrids, which are biofortified with lysine, tryptophan, and provitamin A. And in pod millet, we have got a number of varieties and hybrids which have got iron and zinc a pretty high level, more than 40 ppm. In rice, we are extensively working on low glycemic rice and also on elevating the level of zinc. In zinc, we have identified germplasm as high as 49 ppm of zinc in rice. But the second step is to identify those genes which are controlling the high level and then transfer those genes into high yielding varieties. So this will take some time before we come out with the product with high zinc and more focus on basmati rice elevated with zinc content.
Mm-hmm. And I understand the quality protein maize that you have developed has better quality of protein than that which is found in milk.
Yes, it has got very balanced proportion because the quality of protein in any food matrix is determined by the proportion of different amino acid that it carries. So it has got high lysine and high tryptophan. And now we are also working on methionine, and soon we will have the methionine enriched maize also.
Mm-hmm. Sir, you mentioned about how iron is lost in the process of processing rice because it is found in the bran. Now, increasingly, we are encouraging farmers, particularly in the northeast, in the northwest, Punjab and Haryana, to go in for direct seeded rice. So as to conserve groundwater and so as to avoid transplantation in puddled fields. Now I understand there's a problem over there in terms of the iron content of iron. Is that of rice? Is that right?
Well, I will explain you. The direct seeded rice, as you rightly said, is a very potential technology for conserving water. In transplanted rice, as you know, that for production of 1 kilogram of rice, almost 3,000 to 4,000 liters water is used. Now, if we shift cultivation from transplanted rice to direct seeded rice, there are 3 major problems that happen. One problem is that of weeds, extensive occurrence of weeds. The second is iron deficiency, because iron, when it is available in the aerobic condition, it gets oxidized, so it becomes slightly unavailable. So some soil area which are light soil, there could be problem of iron deficiency. It is not that iron is not available in the soil, but because the form in which a rice plant takes iron, we are changing from a puddled condition to a direct seeded condition. So this is another challenge that the breeders are handling, and we have come out with herbicide tolerant rice varieties which are going to be a boon for direct seeded rice, and this will save about 35 to 40% of water. And also for iron, we are working on this area that in those cases where there is iron deficiency problem, it can be mitigated by external application. But once the root establishment is there, then iron deficiency is not a problem. So it does not mean that iron accumulation in grain will be less. The soil has got iron accumulation in grain will happen, but initial stage, the plants, they face the problem of iron deficiency because it is not available. Plant is used to take iron in ferrous form, and in aerobic condition, it is converted into ferric form. So that some problem there happens, and that's the challenge for direct seeded rice, which we are trying to address by several.
So, are you trying to develop rice plants for aerobic conditions?
Yes. We have already released 2 varieties of basmati rice, which have got herbicide tolerance, and these varieties can withstand with the problem of, you see, I must tell you that water in puddled condition of paddy cultivation was used as the biggest herbicide. You see, after transplanting paddy, if you keep water stagnated for first 15 days, no weed will come up. And that is how this practice of keeping stagnated water in the field evolved over a period of time. And rice became, transplanted practice became adopted everywhere. But then water was available, but now water is a major challenge. So to manage wheat, the herbicide tolerant rice would be a very important area.
And
And we have developed.
the herbicide tolerance that you have created is not through genetic modification. It is not that you have put a gene from some other species into the plant. You have developed it through normal breeding.
Yes, not really. We have the herbicide tolerant rice variety that we have developed. They are developed through mutation breeding, and that's a conventional breeding approach by which we have developed. So it has nothing to do with the genetic modification.
Sir, it's one thing for scientists like you to develop a biofortified cereals, but another for them to be mass produced. For mass production of biofortified cereals, rice, wheat, and maize, we require incentives for farmers. Now, when the government procures for ration shops, it procures on the basis of fair average quality, and there is no incentive or no premium given for enhanced nutrition. Do you think that there should be a premium for enhanced nutrition? And do you think that you should also tie up with private sector companies, let's say like ITC, which have done a very good job in promoting certain wheat varieties like Sharbati, for example, which was not known, very well known earlier on, but now everyone wants Sharbati for making chapatis. So, do you think that we could require good collaboration with private agribusiness companies, and the government must also incentivize the production of biofortified cereals?
So this is one area where we have been, in fact, doing a lot of advocacy at every possible platform. If you look the value of nutrition that the grain carries, 1 kilogram of pearl millet, the normal varieties will have 30 ppm, 30 milligram per kilogram of iron, and 40 milligram per kilogram of zinc. But in biofortified varieties of pearl millet that we have developed, the iron level is 60 parts per million, 60 milligram per kilogram, and zinc has gone to 80 milligram per kilogram of pearl millet. So if you calculate the value of elevated 30 milligram of iron and 40 milligram of zinc that is additionally added by biofortification process per kilogram of pearl millet, and if you assign the value to the iron and zinc based on the value that you pay for a Zincova capsule that people have been taking during COVID period, which comes for 6 rupees, and it provides, the per milligram of iron that it provides. If we convert that value, the pearl millet price should be around 24 to 2500 rupees per quintal. As against the current price is about 2000 rupees. So that 400 to 500 per quintal of pearl millet additional premium because of nutrition. Because you see, the minimum support price is based on cost of cultivation, C2 plus 50% what we are talking about. So that is only taking into account the cost of cultivation, not taking into account what nutrition it carries. And if it has better nutrition, and when people are ready to pay for better nutrition, there should be incentive for farmers to grow it and also develop a complete value chain from production to procurement to processing and to channelization through different government schemes, so that it is public distribution system, midday meal, integrated child development program. So wherever the government subsidy has to be given, it has to be channelized through that. Incentive has to be given. However, in long run, the scientists have accepted the challenge that 5 years, 10 years down the line, there will be no variety which is not biofortified. So we have all varieties of wheat which have got high level of iron, high level of zinc, all varieties of rice with 28 ppm of zinc and higher yield. But doing that, zinc and iron content has its own genetics. We have to identify those genes, map them, identify markers, and then we have genes identified for yield and markers identified for yield. And then we combine the two together through molecular breeding approaches so that we can combine the nutrition with higher yield and we have no compromise on yield. At that stage, probably when everything is fine with better nutrition, then a uniform price can be adopted. But to promote,
Yeah.
incentivize, it will be important to incentivize initially.
So have you made marketing arrangement with private companies for these biofortified cereals?
So, particularly for the maize for seed production, we have tie up with a number of companies, about 10 companies. We have licensed them for seed production. But from seed commercial cultivation to industry, we are talking with the poultry industry also. 75% of maize that goes into poultry industry, and if we feed poultry with biofortified maize, the growth of poultry, the feed conversion ratio, etc., is much higher. So this is one area which has got a lot of promise in future, and the market linkage have to be definitely established. You see, it has happened very well. Many times people ask a question that when the grain comes in the mandi, how do you know that it is biofortified? So if you take the example of mustard, when the mustard farmers bring to the mandi, there is NMR machine available, and you do the oil content, and based on percentage oil that the produce has, the price is determined. Likewise, for iron zinc also, such protocols could be established in the mandi. Those machines can be installed and your sample can be processed. So much so that in countries abroad like US and all, the combines are fitted with the devices. The moment your grain is harvested, it is passed through these machines. Its protein content, its oil content, its micronutrient content, everything is documented, and that slip only farmer has to carry from his combine to those markets to show that this is the nutritional value of my produce, and accordingly the price can be fixed. So I think those advances will come in times to come, and we will have mechanism in place to pay for the nutrition.
So I think in rice there are about 1,200 varieties, and are about 1,100 of them are grown in the country. Now, in traditional breeding, the selection of traits was and the crossing of traits was a time-consuming process. Now, genomics has fast forwarded it, particularly marker-assisted selection of the relevant genes. Now, in the first week of May, the government released genome editing guidelines. What kind of initiative does IARI have for genome editing? And in what way is this going to enhance plant breeding in the country?
So this is a very positive move by the government of India to come out with guidelines on genome edited crops. I must tell you that the mutation, that is sudden change in the genetic material of an individual, this used to happen in nature, what we call as spontaneous mutation. Later people used to do it by induced mutation, by radiation and chemical mutagenic treatment. And but the major problem with both spontaneous and induced mutation was that it was random in nature. Where it will happen, which gene it will happen, the gene that you want to change may not change and something else will change. So all those kinds of problems were there with the randomness and low frequency. And therefore it was a dream of scientists that whether we can make mutagenesis a site-directed process, that the gene that you want to alter, only that gene is altered selectively. And that is what was done by CRISPR-Cas9 system, or the method what we call as genome editing. Now, with this genome editing method, you are only altering a native gene, the gene that is present in the plant already, that gene is only altered. So the protein is also native protein in the plant, and this has got years of history of safe consumption. There is no safety issues involved. Only you are trying to modify the phenotype in a manner that it is favorable for the plants, for the production, for assistance, for quality, and so on. So this genome editing guideline that has come up, it will help accelerate the process of breeding very fast. At IARI, we are already working, and Indian Council of Agriculture Research has got massive program under National Agricultural Science Fund. Almost 7 crores rupees projects have been granted in different crops, not only in rice, in several crops, with a major focus on oil seeds and pulses to improve the productivity resistance to biotic, abiotic stresses, and quality through genome editing. Because many of these genes are characterized, they are well known, and we have to alter those genes by process of genome editing, which can be selectively done. So this is a very positive move, and I think this will pay a rich dividend in years to come in terms of product
Sir,
development.
in the preceding program on this show, we had a geneticist who said that the government's genome editing guidelines are ambiguous and they're not crisp and clear, and they do not provide a clear guideline to the Institutional Biosafety Committee. Now, as a practitioner of, or a likely practitioner of genome editing, what are your views? I'm not asking you to, contradict any particular person, but I just wanted to have your views as a
So
scientist.
I'll just say that one of the major component in the genome editing, the guidelines which have been clear, is to prove that the plant is free from any foreign DNA, right? Now, this is a requirement. How will you prove that a plant is free from foreign DNA? There has to be some protocol, right? So those protocols detailing has to be done, and that can come in the standard operating protocol, which will be developed soon. So one is that you are altering a gene, and what kind of alteration has happened in gene of interest, that has to be characterized at molecular level. That can be done because gene sequence is known, so you can amplify the full length gene, resequences, and then compare with the original sequence, and you know what alteration has happened, which has given you the better phenotype. So this is one part. Second part is that to create this alteration, we use a CRISPR-Cas9 system that has to be removed. That is a foreign DNA element. So for that also, this CRISPR-Cas9 has got number of components. It has a selectable marker, it has a guide RNA expression gene, then it has a promoter. So you can have primers for each of these components, and by PCR you can see whether the developed lines, they are free from foreign DNA. So these are the things which can be, detailed procedures have to be laid down. And in guidelines, of course, this detailing is not given. So this will come in the standard operating protocol. And
But should the guidelines seek extensive data on off-target mutations as well as on stability of the mutation?
So let me tell you, when we talk of off-target, what is off-target? You have a gene under question that you want to alter. Other than that, if some other gene is altered, that is what is off-target. Now, this guide RNA is a very precise way it has to identify the gene that is to be altered. There are bioinformatics tools by which you can predict the off-target site in advance, right? And secondly, even in conventional breeding, when we do breeding by crossing, hybridization, we get good plant and bad plant. We discard bad plant and select good plant. So if there is an off-target, in case if there is a change happens and that phenotype is not desirable for you as a plant breeder, and it is in some gene that you didn't want to alter or change, if any such undesirable effect comes, such plants has to be selected out. Simply you keep a record that these many plants were developed and these plants were not desirable, therefore they have been this happens in the regular plant breeding program. Even if you do mutation by radiation or by chemical mutagenesis, there also you will not always get all desirable mutations. You will get undesirable ones, but as a breeder you will select the desirable ones only. So I think it should be addressed by a phenotypic selection. There is no need actually, in my opinion, to go for whole genome sequencing and then look for in comparison to the original variety, how many deletions are, these things have taken place, which is completely unnecessary. It is not required. You see, any change that has happened in off target, it must have an effect in the phenotype. And if it is adversely affecting phenotype, then it is a matter of concern, then you need to discard that plant. Sometimes you may get, if there is an off target change and that off target change is also good for you, you feel that this can add value, you retain that, there is no need to discard that.
Extreme weather events have been occurring quite frequently, and we have seen that in the case of Punjab and Haryana, this year's wheat crop has been affected by high temperatures in March. And these extreme weather events are likely to happen more frequently in future. So, how focused is IARI in creating climate resilience in plants?
So this is one of our priority areas in breeding, development of climate smart varieties in different crops, and resilience through, we have a project funded by Department of Biotechnology where we have 10,000 land races of rice which have been collected from different parts of the country at different parts of time scale, and we are characterizing those 10,000 land races for their resilience, resistance to insect pest diseases and abiotic stresses, drought, salinity, submergence, etc., mapping the genes, and then using those genes from the traditional land races in developing high-yielding varieties. Developing short duration varieties is another important area because that provides a mechanism to cultivate with less water and also provides escape, from terminal heat stress, for example. Direct seeded rice, one area, again, I said this provides climate resilience to a great extent, and zero till wheat and conservation agriculture. So in conservation agriculture, we are now, taking wheat sowing by, say, middle of October. And therefore, you escape that terminal heat stress as it happened this year. And this will all help in stabilizing production. So collectively, we are working in all crops on climate resilience.
Mhm. And conservation agriculture also helps farmers in accumulating carbon credits. Some time back, we had on this show executives from Grow Indigo who were talking about how they were trying to incentivize farmers with carbon credits. I understand that IARI is also a partner in that program. Could you tell us what role have you played? Are you playing?
Right. True. So this is a very important project, which is having a collaboration with Grow Indigo. Grow Indigo is a partnership between Mahiko and Indigo company from USA, CIMIT and IRI. And they have a major program we have launched on the carbon farming, a carbon credit, and we are moving in that direction. There are a lot of research issues. So it's not just, there are a number of regenerative agricultural practices. And these regenerative agricultural practices, which will help restore environment, includes conservation agriculture is one, then not burning paddy straw, incorporating in the soil, laser leveling, you see drip irrigation or subsurface drip irrigation, anything and everything that can help in enhancing the input use efficiency is a part of regenerative agriculture system. Now, what we have done in the first year of this partnership is that, for example, paddy straw burning or direct seeded rice. If a farmer, this platform provides opportunity for farmers to come and register for carbon farming or carbon trading. And if a farmer registers on the platform, he will register with the coordinates of the field, simply clicking from his mobile. And at that coordinate, my group of scientists here, Dr. Sahgal and others, through satellite imagery, there are 7 satellites from which the data is available. Sitting in IARI, you can monitor at that coordinate whether the direct seeded rice practice has been adopted or not, whether the paddy straw has been burned or not, whether laser leveling has been done or not. So you document that and you verify. Now this, after verifying, you pass on this information to the platform, and this we established from 5,000 hectare area this year. The correlation between satellite imagery based verification is almost 95%. So it's quite accurate. Now, so when farmer is coming and making a claim, the donor has to be sure that the claim made is really correct. So that's the information we have done this time, and this is provided to Grow Indigo. And based on that, a number of people who are going to buy carbon credit, they could be bankers, there could be industry like fertilizer industry, aviation industry, who have their own carbon footprint and they cannot reduce on their own. They can buy the carbon credit from the farmers. So on an average, the current price of the carbon credit per credit of carbon, it's ranging from 10 to $30 US dollar per carbon credit, even $37 up to $37. And in 1 hectare, by following all regenerative agricultural practices, one can earn about 6 carbon credits. So if you get 6 carbon credit at the rate of, say, 30 USD, then you get about 1800, 180 dollars per hectare. That's the credit that you earn, and multiply by 70. So around 15 to 16,000 rupees per hectare is the incentive that will come in the form of this carbon credit by different regenerative agricultural practices. So this is very important area, I think, and this initiative of Grow Indigo is quite appreciable. A number of other companies are also coming forward to venture into this area. I think 10 years down the line, carbon credit will be the most important traded agricultural commodity, more than rice and wheat. It has that much of potential.
Thank you very much, sir, for that panoramic view of the future of Indian agriculture. Thanks very much for joining us.